Okay, so let's have a look at the Leaving Cert Higher Level Maths paper for 2020, paper 1, question 4. So we have this diagram and it shows the functions f of x and g of x. The function f of x is given by this formula here. It's f of x is equal to x cubed plus kx squared plus 15x plus 8. K is an integer, so we're not given k here, and x is real. Okay, so given that f prime 3 is equal to minus 12, show that k is equal to minus 9, where f dash 3 is the derivative of f of x at x is equal to 3. Okay, so what we've got to do is take our original function and differentiate it. So our original function is f of x, and it's equal to x cubed plus kx squared plus 15x plus 8. Now, if we differentiate this, we get 3x squared plus 2kx plus 15. So when we do f dash 3, we get minus 12. We're given that in the question here. And we know that that's going to be equal to 3 with 3 squared plus 2k with 3 in there instead of x and plus 15. Okay, so let's work this out then. We have 3 3s are 9, 3 9s 27, plus 2 3s 6k plus 15. That will give us minus 12 is equal to 27 plus 15, that's 42, plus 6k. And bring the 42 over, you get minus 42 minus 54. And we end up with 6k here, divide by 6, that'll give us minus 9. And that's it, that's all we were asked to do. We were asked to show that k is equal to minus 9, so we've done that. Okay, so let's have a look at part B. So part B, the function g of x is a line that passes through the two turning points of f of x, as shown in the previous page. Find the equation of g of x. Now, in order to find the equation of g of x, we need to use this formula here. So y minus y1 is equal to m into x minus x1. We need two things to put in that formula. We need a point and we need the slope. So if we look back up here at our diagram, we can see that g does go through the maximum and the minimum point here. And it goes through a point somewhere here as well. But what we need to do really is find the maximum point and find the minimum point, the local maximum, the local minimum of f of x. So that's what we're going to do. If we find those 2 points, that'll give us 2 points to find the slope m, and we'll also have a point in here as well. So let's start that then. So we have f of x is equal to x cubed minus 9x squared plus 15x plus 8. So what we need to do is differentiate it. So we get 3x squared plus, that's minus rather, minus 18x plus 15. To find the local maximum, the local minimum, what we need to do is let that equal to 0, because the tangents at the local maximum, the local minimum, would have a slope of 0. So we just need to solve this for x. So we see initially anyway we can divide across by 3. So we end up with x squared minus 6x plus 5 equal to 0 if we divide all the 4 terms by 3. So this just makes it a little bit easier to solve. So we have an x here, an x here. We can put a 5 times 1 here. We need a plus 5, so it's going to be minus minus or plus plus, because this is a minus here. We'll use minus minus. So that'll finally give us an x is equal to 5 or 1. So let's work out what the y values for each of those would be. So let's do that up here. Let's say x is equal to 5 first. Let's work out what the y value would be. So we need to put it into our original function. So it's y is equal to x cubed minus 9x squared plus 15x plus 8. So our y then would be equal to 5 cubed minus 9 times 5 squared plus 15 times 5 plus 8. So that'll give us, let's see, 5 cubed is 125. This will give us 225. 5 15, 75 plus 8, and finally we will end up with minus 17 here. So one of our points is going to be 5 minus 17. The other one then, so we got to work out what the y value for x is equal to 1 would be. So again, let's see, y is equal to 1 cubed minus 9 times 1 squared plus 15 times 1 plus 8. Look, when you work that out, you get 15. So our second point is going to be 115. So we have our local maximum and our local minimum there. So if we just come up here, we can see that we have a 5 minus 17. Well, that has to be this point here. So this is going to be 5 minus 17. And up here, this point here at our local maximum, that's going to be 115. Okay, now normally what you would do is just test this as well, just to see if they are in fact correct. We can see from the diagram they are, but let's say we needed to just check it. We would do a second differential here, f double dash x if you like. So that will give us, we just need to differentiate this again. So that will give us 6x minus 18. So you can see here if you put in x is equal to 5 first, for example, into this, that will give us 6 times 5 minus 18. 6 times 5 minus 18 will give us 12. That's positive. That means we're talking about a minimum. So that's our local minimum. If x is equal to 1, we put that in, and we will get 6 times 1 minus 18. That gives us minus 12, which is negative. So that means we're talking about a local maximum. Okay, so that was just to confirm what we kind of already knew, if you like. Okay, so what do we have to do? We have to find the equation of g of x. So what we need to do first is find the slope of g of x. So our 2 points, remember, are 5 minus 17 and 115. So let's call them x1, y1, x2, y2, and we'll just work out the slope. So the slope is going to be y2 minus y1 over x2 minus x1. I'll just put them in over here. So let's see, that will give us 15 minus 17, so that's plus 17, and 1 minus 5. So 15 plus 17 is 32 over minus 4. So 4 8's 32, so it's going to be minus 8. So our slope is minus 8. So we need to put all our information into this equation here. So let's pick, well, we pick this one here, I think. You have a choice of points. So it's going to be y minus 17, so that's y plus 17. Y minus minus is plus. You've got minus 8 here, and you've got x minus 5. Let's just work that out. So we've got y plus 17 is equal to minus 8x plus 5 eighths 40. And let's just bring everything over to one side. So we've got 8x plus y plus 17 minus 40. That's minus 23, I think. Minus 23, yeah. Now we can also write that in the form y is equal to mx plus c. So y is equal to minus 8x plus 23. We could write it that way either. Either one is fine. So they would be our versions of our equation of g of x. So this would be these would be g of x. Okay, so last section then, we've got to show that the graph of g of x contains the point of inflection of f of x. Okay, so if we have a look here at our original graph, you can see here that it does look like it's going through the point of inflection here. So what we're going to do is just work out what the coordinates of this point here are. So the way we're going to do that is we're going to differentiate the original function twice. Now we've already differentiated it once, and we got f dash x is equal to 3x squared minus 18x plus 15. So if we differentiate a second time, we get 6x minus 18. And what we need to do is let that equal to 0 and just work out what x would be. So 6x is equal to 18, and then we'll find that x is equal to 3. Now if x is equal to 3 then, if x is equal to 3, we put that into our original function to find what the y would be. So that would be, let's see, it was 3 cubed, and then it was minus 9 times 3 squared, and then we had a plus 15x, so that would be 15 times 3, and then we had a plus 8 out at the end. So that will give us y is equal to 27 minus 81 plus 45 plus 8, and that should give us minus 1. Y is equal to minus 1 here. So we know that our point of inflection then is going to be 3 minus 1. 3 minus 1. Okay, so the question actually asks us to show that the graph of g of x contains the point of inflection. So let's just do that then. So what we need to do here is show that 3 minus 1 is on g of x. So we need to pick one of our equations that we had up above. I'm going to pick this one here, 8x plus y minus 23 equal to 0. So let's put x and y in here and see what we get. So our x is 3, so we put that in there. Y is minus 1, so we put that there. Minus 23 equal to 0. That'll give us 3 eighths. 24 minus 1 minus 23 equal to 0. And I'll just come over here because I'm running out of room. So 24 minus 1 is 23. Minus 23 equal to 0. So that will give us 0 is equal to 0. So therefore, I can put it down here just at the end. Therefore, g of x contains 3 minus 1, the point of inflection of f of x. And that's it for this question.